Hi, my name is Mike, and I'll be talking about sticky, gecko-inspired space robots. On Earth, we use robots in applications where it's unsafe for humans to operate. For example, inspection and repair of a hydroelectric dam. In space, we love to do the same thing. Imagine a robot crawling along the exterior of the International Space Station, performing a minor hardware upgrade so that astronauts don't need to suit up for a spacewalk. Unfortunately, with today's technology, this robot would just fall off into space because there's no way of sticking the robot to the exterior of the International Space Station. We can't use magnets because spacecraft exterior parts are generally made from aluminum or composite, which are lightweight but not ferromagnetic. A suction cup is also a no-go because a suction cup requires ambient pressure to hold it in place, and in space all we have is a vacuum. The adhesives that you and I would use at home, for example, duct tape or Scotch tape, they work because of a thin tacky layer on the surface. But when you expose this tacky layer to vacuum, then it just boils off or outgasses. Now the gecko on the slide behind me is not a spacefaring species, but it has an interesting characteristic, which is a bunch of very small hairs on the bottom of its feet. And when these hairs are brought into close contact with the surface, they conform very nicely to the surface roughness, allowing the gecko to stick to almost any material on Earth. And this is what makes a gecko such a great climber. In my lab, we managed to fabricate a material which replicates the functionality of the gecko's foot in PDMS, which is a bit like rubber. My contribution is the robot behind me, which is a 6-legged robot with synthetic gecko adhesives on each of its feet, allowing it to climb vertically, perform some dexterous maneuvers, and it also has a nice factor of safety. If one of the legs detaches from the wall, there's still 5 feet sticking to the wall holding it on. So this dexterity and the factor of safety are great for a space application, but what else do you need to put this robot into space? Well, we'd like to be using radiation-hardened components and materials that won't outgas, but what about the adhesives? Could they actually work in space? Well, we weren't sure either. So last summer, I took samples to the European Space Agency and did some tests. I put them in vacuum, I lowered the temperature to -50 and raised it to +75 to simulate a space environment, and then measured the adhesion forces. What we found was pretty astonishing. There was absolutely no decrease in adhesion between the simulated space samples and the ambient laboratory samples, meaning that a robot up on the International Space Station sticking would stick just the same as a robot prototype in an ambient condition in the laboratory, paving the way for a sticky, gecko-inspired space robot. Thank you.